Hello and welcome to the third and final part of your lecture on the structure of the nervous system. In part one, we discussed the basic features of the nervous system. In part two, we discussed the structure and function of the central nervous system. In this lecture, we are going to talk about the structure and function of the peripheral nervous system, also abbreviated PNS. In so doing, we're going to identify the functions of the cranial nerves, differentiate between afferent with an A and efferent with an E axons of the spinal nerves. We're also going to compare and contrast the sympathetic and parasympathetic divisions of the autonomic nervous system, or ANS. So on to the structure and functions of the peripheral nervous system, focusing on cranial nerves, spinal nerves, and the autonomic nervous system. There are, as you can see from this illustration in your textbook, 12 pairs of cranial nerves. So they come in pairs. They are attached to the ventral surface of the brain. Most serve some sensory and or motor function of the head and neck region. It's important to note that even though they emanate directly from the brain, they are not part of the central nervous system, but rather histologically more similar to parts of the peripheral nervous system. The vagus nerve is one of these, and it regulates the functions of organs in the thoracic and abdominal cavities. The olfactory information that we get through our nostrils is received, for instance, by the olfactory bulb. And these are easy to see. Here is the vagus nerve, and the olfactory nerve is labeled here and goes right in there. So the 12 cranial nerves include nerve 1, the olfactory nerve, which is sensory fibers, which represent sensory fibers. Information is taken in through the nostrils and transmitted to the brain for processing in an ipsilateral fashion. And you'll know what that means, same side, from the earlier lecture. The optic nerve, cranial nerve 2, is also sensory. So sensory fibers are labeled with blue, and motor fibers are labeled in red. So the optic nerve, cranial nerve 2, carries sensory information into through the eyes, so visual information into the brain. The oculomotor nerve, cranial nerve number 3, represents motor fibers that control the muscles of the eyes and its movement. So when you roll your eyes, that's your cranial nerve 3 working. The trochlear nerve, cranial nerve 4, represents motor fibers that control the muscles of the eyes and its movements as well. And they differ in that, they are involved in, differently involved in rotation of the eyeball versus operation of internal parts of the eye, such as the dilation and constriction of the pupils. And we'll talk about that more later on. The trigeminal nerve is a sensory nerve that takes in muscle information from the jaw muscles And it also has motor fibers that control touch and pain sensation. The abducens nerve, which is cranial nerve 6, controls muscles of the eyes and its movements as well. And the facial cranial nerve 7 represents sensory fibers of taste and motor fibers that control muscles and movements of the face. And finally, the auditory nerve is cranial nerve 8, that is involved in hearing and balance. The glossopharyngeal nerve is cranial nerve 9, that's involved with taste and also with control and movement of the muscles of the throat and the larynx. The vagus nerve, as I mentioned before, is involved with sensation and motor control of muscles of the internal organs. And the spinal cranial nerve 11 is involved in the control of muscle movements of the neck. And the hypoglossal nerve 12 is involved in the control of muscles and movements of the tongue. This illustration from your textbook represents a screenshot of a video specifically on the vagus nerve that I'd like for you to view in your own time. Right now, we're going to move on and talk about the spinal nerves. So the spinal nerves leave the vertebral column and travel to the muscles of or sensory receptors that they innervate or supply. They branch repeatedly as they go, being sure to cover lots of territory. They fall into two categories, afferent with an A and efferent with an E. The afferent axons bring information inward towards the central nervous system, that is the brain and the central column of the spinal cord. The efferent axons send information outward. The center of the spinal cord is shown in this illustration as a butterfly-shaped bit of gray matter. It has a thick area shaped like two hemispheres that are fused at the vertical side, which is the white matter surrounding the gray matter. So this illustration also reveals the pia matter, which you can see it's labeled here, surrounding the white matter. And it also shows the dura mater and the arachnoid membrane. So this is very similar to what we see in the encasing of the brain. The difference being here in the central nervous system, we're focused on the spinal cord. The autonomic nervous system is a collection of fibers that support a variety of functions that are really important for understanding brain and behavior. The target organs and functions served by the sympathetic and parasympathetic branches of the autonomic nervous system are illustrated here. Blue represents the parasympathetic functions, and green represents the sympathetic functions controlled by various nerves in the autonomic nervous system. You'll also see some items illustrated in red, which also represents sympathetic functions coordinated by the lumbar spinal nerves, and some items illustrated in yellow, which represent parasympathetic functions coordinated by the sacral spinal nerves. But generally speaking, the sympathetic division represents our fight or flight, and that's here. And the parasympathetic division represents our rest and digest functions. The autonomic nervous system as I've mentioned before, falls into or is divided into two categories. It is really a branch of the peripheral nervous system. And as such, it's concerned with the regulation of smooth muscle, cardiac muscle, and glandular tissues, which will become increasingly important for your understanding of brain and behavior. The two anatomical systems, again, are the sympathetic division and the parasympathetic division of the autonomic nervous system. The sympathetic division of the autonomic nervous system controls functions that accompany arousal, the expenditure of energy. It also coordinates fight and flight or freezing in response to a stressor. By contrast, the parasympathetic division, as I mentioned before, is that part of the autonomic nervous system that happens to be activated in instances where you are prompted to rest, to invest energy in digestion, in growth, in cellular repair. As you might imagine from your viewing of the movie Heal, these functions are incredibly important for recovery from illness and for also prevention of illness. So this is another screenshot I'm including here just to remind you that there's a handy video supplied by your textbook publisher that highlights the functions of the autonomic nervous system and is also important to watch in your own time. I'm going to wrap up this lecture just summarizing the important components of the peripheral nervous system. So first we have the autonomic nervous system that we've talked about primarily today, and that includes the sympathetic branch and the parasympathetic branch, all those spinal and cranial nerves and sympathetic and parasympathetic ganglia that make up that system, that part of the peripheral nervous system, and the somatic nervous system, which we didn't spend quite as much time talking about, but which really represents the spinal nerves, the afferent intake projections that gather sensory information to bring into the spinal cord and brain, and the cranial nerves that send both afferent or efferent content. So that's it for today, and that also concludes this unit. Happy reading.